Today we are going to discuss about the membrane potential and action potential. Here shown in the diagram, the structure of a typical neuron and muscle cell. The neurons and the muscle cells are capable of generating rapid changing electrochemical impulses at their membranes. A nerve cell that exhibits a resting membrane potential is said to be polarized. In nerve and muscle cells, membrane potential in resting state is referred as resting potential. In nerve cells, resting membrane potential is about -70 millivolts, with the inside of the cell with negative potential. The membrane potential of a neuron can be measured by using a device called microelectrode. Here shown in the diagram, a typical neuron and its components. Electrical impulses are used to transmit signals along nerve or muscle cell membranes. For the purpose of better understanding, we are going to draw here the cell membrane of a nerve cell. Cell membranes of a neurons have powerful sodium-potassium pump and sodium-potassium leaky channels. On the cell membrane of the neurons are present the sodium voltage-gated channels and potassium voltage-gated channels as shown in the diagram here. Sodium-potassium pump, electrogenic in nature, pumps 3 sodium ions to the outside for each 2 potassium ions to inside. By utilizing ATP, a high energy molecule, thus is energy driven, leaving net deficit of positive ions on the inside. This causes the negative potential inside the cell membrane. A channel protein in the nerve membrane through which the potassium and sodium can leak called potassium-sodium leaky channels. On an average, the channels are more permeable to the potassium than to the sodium. Another type of the protein channel called mechanically operated sodium channels, which are very much sensitive to touch and hence are touch receptors. Present on the nerve cell membrane are sodium voltage gated channels with activation gate and an inactivation gate. At resting state, the activation gate is closed and inactivation gate is open. In this state, the activation gate is closed, which prevents any entry of sodium ion to the interior of the fiber. Another type of the protein channel called potassium voltage gated channel. During the resting state, the gate of the potassium channel is closed and potassium ions are prevented from passing through this channel to the exterior. The diagram here depicts the cell is in the resting state. The membrane potential of the cell is -70 millivolts. Here we are going to draw the graphical representation of the membrane potential. The membrane potential of resting neuron is -70 millivolts. And here this -55 is the threshold for sodium. When we touch the neuron, there is a little distortion in the membrane. The touch sensitive channel slightly open and little bit sodium will come in. The stimulus was very little and could not take it to the threshold and eventually will die out. But this time the stimulus is enough strong and the stimulus will reach to the threshold. The activation gate of the voltage gated sodium channel will flip open and will bring massive amount of the sodium inside. The membrane is losing its negative polarity, or simply the membrane is depolarized. Before sodium ions could reach up to the sodium equilibrium potential, the inactivation gates are closed. Rapidly, K positive start leaking outside, positive charges are being lost outside, so it is repolarizing itself. Sodium voltage gated channels are slugged close. K positive will diffuse outside. Cell will go below the threshold and is said to be hyperpolarized. From this point to that point, sodium voltage gated channels are open. Before it could reach up to the sodium equilibrium potential, the sodium voltage gated channels are closed, here shown in the diagram. Now, inactivated gate is closed and activated gate is open. Sodium influx will abruptly stop. At this point, potassium voltage gate channel will open. As rapid positive charge starts leaking outside of the membrane through the potassium voltage gate channels, the positive charges are being lost outside. Inner side will become more and more negative. The membrane will remain permeable for K positive. For more, K positive may diffuse outside. Cell may go beyond the threshold, called as hyperpolarization. From that point, the cell loses its positive charge and is said to be repolarized, and is called as a repolarization. Potassium voltage gated channels are slugged close. More K positive may diffuse outside and the cell will go below the threshold and is said to be hyperpolarized. This was all about the membrane potential. In the next lecture, we are going to discuss the action potential. Thank you.